I want to close out this discussion of photons by talking about their momentum. So previously we found that for electromagnetic waves we could derive a force due to the waves because the waves carry momentum. And this force was equal to the power in the waves divided by the speed of light. Now we can convert this back to a momentum equation using dp equals f dt. So it means a little bit of momentum is force times a little bit of time, and we can integrate that up and say the integral of dp, which gives us the total momentum, is 1 divided by the speed of light times the integral of the power dt. Now the integral of the power over time is nothing more than the energy. So that means the momentum must be equal to the energy divided by the speed of light. And you've seen this before when we're talking in the context of special relativity in the previous part of the course. And you saw that for a massless particle we had that momentum is equal to E divided by C. And so this is true for photons, and so we get that for a single photon with energy given by Planck's constant times the frequency, we have momentum is h nu on c, which is equal to h divided by the wavelength. And so this is the momentum in a single photon. Now, I've derived this here for massless particles and done it for photons. Turns out that you can interpret this equation and come to the same conclusions much more generally for particles with mass. And so this, in fact, this relationship, the momentum is equal to h divided by lambda, is much more general and tells you the wavelength of something depending on the momentum. So you can write the wavelength of something is h divided by the momentum p. So if you're talking about the motion of an electron or a proton or an atom, the wavelength of this thing can be calculated using this equation. And this, for example, will tell you something about how the interference fringes work if you do a double slit experiment using electrons. And we'll talk about this a little more in the diffraction section of this course.